In this video, we're going to create some truth tables for more complicated compound statements. So you want to have on hand the completed truth tables for the 5 basic connectives for conjunctions, disjunctions, conditionals, biconditionals, and then also the negation. Alright, so we're going to refer back to those as we go. Okay, so we're going to create a truth table for the statement not P or Q. Right, so to start out, you would scan the entire statement and just see how many simple statements we're dealing with. Okay, so you would count the letters. We've got 2, P and Q, and you would start off with a column for each one of those. Then next you would list out all of the possible true and false values for P and Q, and it would help if you did stick with the standard order for these, and that's to do the trues first, followed by falses. So we have 4 different possibilities for P and Q together. All right, so P could be true, Q could be true as well, P could be true, Q could be false. If P is false, Q can either be true or false. All right, so that will always look the same for any of these examples we'll do with P and Q. Okay. Next, we have a couple different connectives, and well, we have one connective and then one negation symbol here. So we need to decide what we're going to do next. Are we going to see if the negation of P, what its possibilities are, or are we going to deal with this or statement? So we have an order of operations for logic symbols. It's called the hierarchy of connectives, and it basically just tells you what order to examine the true and false values for these statements. All right, so we go from the top down. We would start by looking at any negations, and then we would move on to conjunctions or disjunctions, followed by conditionals, and then by biconditionals. So if there are no parentheses, you would go in this order. Okay, so let's say we had like not P and Q, an arrow for if then, and then R and I don't know, let's do not S. Alright, so no parentheses, but I would start with negations. So if I wanted to, I could put these in parentheses. Okay, then I would do conjunctions or disjunctions. Okay, so I have an or here and I have an and here. And then finally I would do this conditional. So back in this statement, I would do the negation first. So I'm going to make a column and look at the truth value for not P. Okay, and remember we're just considering these 4 cases for P and Q. All right? And then I would go on and look after that. I would move on to the or, and I would look at the truth value for not P or Q. Now there's an example in your textbook of what kind of a statement this would be. So not P or Q would be something like, my leg isn't better, or I'm taking a break. So what we're trying to do here is see, we're thinking of my leg is better as P, okay, and I'm taking a break as Q, and then we're just examining the 4 situations. What if my leg is better and I am taking a break? Is this true or false? What if my leg is better, I'm not taking a break? What if my leg isn't better and I'm taking a break? And what if my leg isn't better and I'm not taking a break? So those are the only 4 possibilities for this compound sentence or statement, and we want to make sure that we know whether this would be a truth or a lie in each of those 4 situations. So that's our ultimate goal with constructing one of these tables. Okay, so we have looked at the 4 cases for P and Q. Now in each of those I want to see if not P is true or false. Okay, so this is where I refer back to those basic tables. So I'm going to look now at the negation table, and that was the one that had columns for P and not P. Right? So when P is true, then not P is false. Okay? When P is, and that repeats here, when P is false, then not P is true. Okay? So I've pulled that from that basic negation table. All right, next I want to look at not P or Q. Right? So I already have a column for not P. I already have a column for Q. And now I want to follow along with the rules in the basic truth table for or statements to decide in which cases this or statement is true and in which cases it's false. All right, so go back and look through that basic table for disjunction or statements, and we said that those or statements are always true unless both statements on either side of the or are false. Okay, so if we had false or false, then it would be false. All right, so I'm going to look at the not P column and the Q column, and I'm just going to scan through and look for any cases where both of these are false. Okay, so I have a true or false. That would be true. Here it is. Okay, if both are false, then that statement would be false. If both are true, that would be true. And if one is false but one is true, it's still a true statement. All right. So basically, my sentence, my leg isn't better, or I'm taking a break, that's true most of the time. It's only false when the first part is true, and, well, when P is true, and when Q is false. Right? So in the situation where my leg is better, but I don't take a break, okay, then that would be a false statement. Okay, so if you're sort of just wondering, like, well, what does the answer to this type of problem look like? This entire thing is your answer. Okay, so the goal was to construct a truth table, and we were just trying to show all of the different possibilities for this statement being true or false. We could go on, and an application of these truth tables would be to then look in specific cases and say, okay, well, now I know, I know P is true and Q is true, and then we would follow it all the way over and say, oh, okay, well, then that statement is true. Okay, so let's look at a second example. We have the negation of a conditional P, if P, then not Q. All right, so no matter how complicated this gets, you're going to start out the same way, scan through and look at how many simple statements are mentioned, okay, or how many variables there are. So again, we just see P and Q, so I'm going to set up two columns, one for P and one for Q. And I start out the same. P is true, true, false, false. And then we have true, false for Q. All right, next I'm going to use that hierarchy of connectives to see what I should do. All right, so here, if there are parentheses, I want to pay attention to those and do those first. Okay, so if I'm going down that list, down the hierarchy, I would start with negations, but I'm not going to start with this one on the outside of the parentheses because there is a set of parentheses there. All right, so I'm going to start with the parentheses, and then I have two choices in there. I could look at the conditional, or I could look at the negation. So now I do follow that hierarchy, and I'm going to start with the negation before I do the conditional. So I'm going to look at the truth value for not Q next, and then after that I'm going to look at the truth value for the conditional. P, right, implies not Q, or if P, then not Q. And then finally after that, now that I've done the parentheses, now I can go on to the last thing and look at the negation of that whole parentheses. Okay. So now we would start with the not Q column. Oops. All right, so now I want to compare Q and not Q. I'm going to go through and use that basic truth table for negation. So if Q is true, then not Q is false, and vice versa. And these are always just going to be the opposite of whatever you see in the Q column. False, true, false, true. Then next I want to look at an if-then statement. So we haven't done one of these yet. Right? So go back to the truth table that has the rules for conditionals, and we had, there was only one situation where these are false, and that was if we had the first part true and the second part false, then that would make the entire statement false. Otherwise, this would be a true statement. All right, so I'm going to find my two columns on either side of the arrow, the P and the not Q. Okay, and I'm going to focus on those and look for any cases where I have true followed by false, because that's going to be an indication that we have a false statement. So here it is right away. I have true followed by false, so that's false. And that's it. The other ones would all be true. So I have true followed by true. That's true. Okay, and then if the first part is false, and then in both cases, that would be a true statement. All right, now, finally I want to look at the last negation. So I'm looking at the negation of the parentheses, and this parentheses, I already did a column for this. Okay, so I'm going to refer back to that column, and then write down the truth value for the negation of that. So in other words, just the exact opposite. So if this one was false, now I'm going to write true. And in these three cases where it was true, now I write false. And that's it. All right, let's do another one. So scan through, and we see actually 3 variables this time. So this is the first example we've done with 3 different simple statements. So this would be something like, it rains, or if I go to the movies, then I will buy popcorn. Okay, so we've got 3 different statements to consider. So now here's the question. I know I need a column for each statement, but how many rows are we going to have? All right. So this is, again, we can go back to that interesting connection with the fundamental counting principle. So I know I'm going to look at the options for P, Q, and R, and then multiply. So P can either be true or false, Q can be true or false, and R can be true or false. And when you multiply, now there are 8 different possibilities. Okay, so when I go through, I'm actually going to have 8 different rows. And here's how we do it. We would now put all the trues before falses. So we start out with P, and P is going to be true in 4 of those cases, 4 out of 8, and then false in the other 4. Then Q, we're going to go by 2's here. So these will be true, true, false, false, true, true, false, false. And then R goes every other one. True, false, and so forth. Okay, so can you see what this would look like if we went on to, maybe I added in like a 4th statement, S? So then I would have 16 different options, and I would start out with P. I would do like 8 trues for P and then 8 falses. Then I would do 4, and then I would stagger like 4s and 4s for Q's. So 4 true, 4 false, 4 true, 4 false. Then R's I would do 2 true, 2 false, so forth. And then S I would do true, false, true, false. Okay, so look through this list and make sure that you're convinced that we have all of the different options. Okay, so I have the case when all 3 are true. I have the case when all 3 are false. I have, and basically every combination of trues and falses for these 3 things. Okay? All right, So then we go on and we would again look at the hierarchy of connectives to decide what to do next. So this time I have parentheses, I have a conditional, and I have an or. So we start with the parentheses. Okay. And notice they are really necessary this time, because if they weren't there, I would have P or Q, then R. And based on the hierarchy, I would do this or first, followed by the conditional. Okay, so it is really important in this case to put in those parentheses as we've been given in that statement. Okay, so I start with the parentheses, and I'm going to look at the truth value for if Q then R. Right? And then after that, I'll go back and look at the or, so P or the parentheses. Okay, so if Q then R. So I'm going to look at the Q column and the R column, and look at my basic truth table for conditionals. So again, this is only false if I have true followed by false. Okay, so if the conditions of that statement were met, but the conclusion was false. All right, so I would look through and find any TFs. So I've got a TF here and a TF here, and in both of those cases, the statement is false. And in all of the other cases, the statement would be true. So I'd fill in trues. True, 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 false, true, true. Okay, and then after that I would do this or statement. So I want to look at the two things on either side. So I want to look at the P column and then also the column for if Q then R. And then I would refer to my basic table for disjunctions, for or statements. And or statements are only false if you have two falses. So if it was false and false. Okay, or false or false. All right, so I would look at this P column and then this one. So I'm going to ignore the Q and R columns. I don't need it for this piece of the table. And I would scan through and look for anywhere I have both falses. Okay, so right away these first four, P is true, so those are all going to be true. And then it's these last four I need to worry about. So I have false and true. That's true, because I only need one piece of the or statement to be true. Then next I have false or false, so that's false. False or true is true, and false or true is true. All right, so basically this type of a statement, this is true most of the time. There's only 1 out of 8 cases where this is a false statement. All right, I did want to say something about this one, and so far with these if-then statements, we've only looked at examples where the columns, like this is if Q, if Q then R, and we've had Q and R lined up like that nicely from left to right. So it can be a little bit trickier when that's not the case. So let's change this a little bit, and let's say that we were constructing a truth table for P or if R then Q. So we'll get to go with P or if R then Q. All right, so it's similar. I'm going to start with if R then Q, and then go back and look at the or statement. Right, but now when you're looking at R, if R then Q, you have to remember that the R is the thing that's coming first. Okay, so when I look at like this one, for example, and when I refer back to the basic table for conditionals, this isn't the case where it's true, if true, then false. I'm reading this backwards. This is if R then Q. So I'm actually looking here at the case, what if it's if false, then true. So you have to read this backwards. Right? So when you're looking through, and we know conditionals are only false if you have true followed by false. So I would want to look for cases where R is true and Q is false. Okay, so that would be this one and this one. And everything else would be true. True, true, and true. All right, so just pay attention to the order. It doesn't matter for and statements, and it doesn't matter for ors, obviously not for negationals, and then the biconditionals are only true like if it's both true and both false, so that's not as tricky to look at either, but it's really just these conditionals that can be kind of a headache if you don't get the order correct. Okay, and then I'll just finish this one off. So we have P or the column for the conditional. So I'm just looking through for any examples, any cases where they're both false, and the only case I have that is this one down here. Okay, so that would be false, and then the rest, the other 7, would be true. 4, 5, 6, 7, 8. All right, I'm going to start these off. This is example 4 from the textbook, and I don't want to go through and make truth tables for all of these, but I think it would be helpful to at least talk through the hierarchy of connectives and how you would set up the truth table. So first of all, if we have not P or not Q, so negations come before ors. So if you wanted to rewrite this with parentheses, you would put those around each of the negations. All right, so when you go to make your truth table, you would do a column for P, a column for Q, then you would do a column for the negations, so not P, one for not Q, and then finally you would do a column for the last connective, the or. The next example, if P, then not Q, and R. Right, so following along that hierarchy list, negations would come first. All right, so we could do parentheses there. Then those are followed by ands and ors, so parentheses there. Okay, and then finally the conditional. Now a lot of times we won't write that double parentheses, so if I just write this, that would be sufficient, because inside the parentheses I would know to do negations before I would do these ands. All right. The next one, we have 2 ors and a biconditional. So the ors come first, so you could put parentheses here and here. Okay. Oh, let's back up. I didn't do a truth table for this last one either. All right, so we would have, okay, for part B, we would have columns for P and Q and R, right? And then I would do the parentheses next, and within the parentheses I would do the negation first. So I would do the negation of Q, okay, then I would do the and then finally I would go back and do the whole conditional. Not Q or and R. All right, in part C, we would do columns for P, Q, and R. And then I would do the 2 or statements. So I would do P or Q, Q or R. And then I would do a column to deal with this conditional. So I would do P or Q, and if and only if, Q or R. Right. So in this one I would be using the basic table for biconditionals, and I would be referring back to these 2 columns. Okay, and then finally in the last case for D, so columns for P, Q, and R, and then we would do, following along with the hierarchy, conditionals go before biconditionals, so this would get a parentheses. So I would next have a column for if P, then Q, and then finally I would have a column for if P, then Q, and then I'm focusing on the biconditional in this column, and then R. Okay, so I would look at the column for if P, then Q, and I would look at the column for R, and then I would use the basic truth table with the rules for biconditionals. All right, so that's it. Those are some examples. So again, as you're making these truth tables, make sure you have on hand the 5 basic truth tables, and then follow along with the standard order for writing the rows and columns for P, Q, and R, or whatever variables you have involved.